So the first pre-step is the system of equations here must be in standard form. Standard form is the ax plus by equals c. We have to do it that way because that is how our matrices are structured. So the first equation is written correctly already. But how do I rewrite what we call the slope-intercept form? Very good. I need to move the x over by subtracting it. So now this becomes a negative 3x plus y equals 1. All right. This is now in the appropriate standard form. Now I can write out my equation. What, again, my equation from yesterday is Lx equals b. What would my L be? Very good. If there's no number there, there's an imaginary 1 right there. So this would be a 1. Your x is going to be x and y. Those are the variables you're trying to solve for. And then your b would be what it's equal to. What's it equal to? 1, 1. All right, so that was the setup. That's where we kind of started from. And then we solved this using inverses. So the first thing I need to do is I need to determine, well, does this even have one? So this is going to be AD minus BC. So my A is 6 times 1 minus 2 times negative 3. What is 6 times 1? What is a negative, or what's a 2 times negative 3 and then a negative applied? A positive 6, because this will give you a negative 6. Applied the negative gives you back to a positive. So 6 plus 6 gives you 12. So does this have an inverse? Yes, it's not 0. This definitely does have an inverse. So now I go find this inverse. So the inverse here would be 1 over 12, because that is, again, from yesterday's notes as a reminder. This is your inverse. You have something to add? It means that we should pay attention to the lecture, and Jacob can explain that at a later date. All right, again, so this is the equation we use. We've talked about inverses before. So now, what will this new matrix become? Perfect. All right, so there's my inverse. I suggested to you when we did this to not distribute that 1/12, deal with the fraction at the end. What do I do, though, with this inverse? What do I need to multiply it to? The b, which is the 1, 1, making sure that you keep it on the left side. So here we go. I write the scalar on the left to avoid that at the very end. And now I'm ready to do my work. How do I multiply? Row by column. So 1 times 1 is 1 plus what's negative 2 times 1? Row by column again. 3 times 1 plus 6 times 1. And again, if you did that work already, I'm okay with that. I just want to show you the complete process. 1 plus negative 2 is, and then 3 plus 6 is 9. All right. I did warn you that we are going to get to points where it's not going to be pretty numbers, and this is one of those situations. So what would my final answer be if I now applied the 1/12? Negative 1/12, and good. You would get 9/12. We do need to reduce that. And if you did it all at the very beginning, that is fine by me. But 9/12 would give you the 3/4. That is your answer. And of course, if you don't believe it, you can always take it, back substitute it in for your x and y, and just prove that it does equal. Any questions on that? All right, let's move on into B. What you get for B as the answer real quick, just so I can get a head count. Yeah, well, what you get for your answer for B? Y. Awesome. Very first step, when you are building your equation, what's my equation going to be for Lx and B? Perfect. And here's your x, y. And just to make sure we understand, what's our b? 10, 1. But before I can actually solve this equation, I need to go find its determinant, which again is AD minus BC. So that's going to be a 4 times -3 minus -6 times 2. 4 times -3 gives me -12. And a -6 and a 2 and then a negative applied would give me a what? A +12. And a -12 plus 12 gives me 0. So because I got 0 as my determinant, not possible. Meaning there is no two numbers, x and y, in which both of these statements will be true. Do y'all remember what that looked like graphically back in Algebra 1 if you had no solution? It's something. It's a graph. I'll give you a hint. If to have a solution on a graph, it intersected. To have no answer, they were parallel. So that's what these two lines would do graphically, is they would be parallel lines where there would not be two answers that would give you the same thing. If you're looking at the next example there, that's just giving you a connection to your rotations and things like that, and then also making you just kind of practice some more. I'm not going to go over that question, but if you need want to go over it and you want me to check it later, I don't mind doing that. We need to now transition into lesson 15. Where is 15 at? I believe you have an opening exercise, and I want you to start there. The opening exercise is just asking you to solve one, write a system of equations. So that's two equations. Solve it by your method, either algebra or what I've shown you. And then I believe after that, actually, it wants you to do both. Solve it using algebra from Algebra 1 or Algebra 2, and then part C using my method or the method that we learned yesterday to finish it up. So instead of staring out in space, we are working on the opening exercise, which I believe is on page 115. So again, just like on an ACT question, you have to just be able to write a system of equations off a word problem. And for my juniors, I'll be seeing some of you on Tuesday for your ACT. If you can at least answer A, I'm not going to stress too much about B and C. I want to make sure you can still produce an equation. All right, does anyone need more time to do part A? Or are you at a stumbling block? All right, in Algebra 1 and Algebra 2, when we taught how to do systems, especially with word problems, the first thing is to identify your variables. Typically, you always have two variables. Today, we'll be seeing three variables, but for this one, it's still just two. What are your two variables here? What specifically about A and B? The stream. Very good. So I'm going to come over here and I'm just going to do some pre-work. I'm going to let A represent stream A. and I'm going to let y equal stream B. If you like A to be stream A and B to be stream B, that is completely fine. I'm just trying to label my variables, all right? So I need to know what two variables are going on. After this, you're just translating words into math symbols. So let's kind of read this. It says, Mariah was studying currents in 2 mountain streams. She determined that 5 times the current in stream A. All right, so let's just stop there. How would you represent 5 times the current of stream A? Just 5 times A, right? Or in this case, 5 times X, since we let stream A represent X. So there's the beginning. It literally says 5 times stream A. If we let stream A be X, that would be 5X, or 5 times X. Now, there are 2 words that represent the equal sign, is and was. So if you see the word is or was, that's going to represent a equal sign. All right, so anytime you see this word here, is a equal, and it's is or was. So it's going to be something is this or something was this, right? But that means that they are equal in some value at some given time in that scenario. Then it says 8 feet per second stronger than, we'll get to that point here in a second. So 8 feet per second stronger. What would that be? Right? Larger, right? What do we do with that? It's just 8 seconds stronger, larger than something. What does that mean? What operation would that be? Not quite greater than. So we're not going to throw in any inequalities yet, but that is a good point. Addition. Very good. Think of it like you have $8 more than someone else. You will add 8 to whatever you have, right? So when I read this and I see 8 feet per second stronger than, this stronger than means or larger than or more than or something in those sense of words, all just means a plus sign, right? So this is going to be 8 plus something. I don't know what is something yet. And it says plus twice the current in stream B. How would you represent that in symbols? 2y. If I'm letting stream B be y, that would just be 2 times y, because that's what twice means. Twice means 2 times something. There's your first equation. Now you read the next sentence and you do the same concept. Turn words into math symbols. Obviously, I can't turn Mariah into a math symbol because it's a name, right? So there's certain words that aren't math symbols, but there are a lot of words here that do represent math symbols. You have to be able to pull those out correctly. Typical equations can be written in order as the sentence goes. There is one phrase that goes backwards. Anytime you ever see the word less than, like, so if this would have said 8 seconds less than something, you write it as 8 minus. So if you ever see that word, you have to start going backwards. Other than that, it's pretty straightforward of reading the sentence from left to right, if you recall that from algebra. All right, here we go. Another day, she found that double the current in stream A. So how do I write double stream A? Just 2x, or 2a if you let A be stream A, plus, that's a big one. What's plus going to be? A plus sign. 10 times the current in stream B. What was that? 10y. Was. What does was mean? Equals 3 feet per second. Just the number 3. This is ACT style questions. Now, granted, it is multiple choice, so you can use the words and kind of figure out which symbols represent that sentence better to kind of help guide you, but be able to produce something like that. Part B is asking you to use your algebra skills from Algebra 1 and Algebra 2 to solve this. There are 2 ways to solve this. You can have the addition elimination method, and you can have the substitution method. All right. Honestly, I always go with the addition elimination, but for sake of today's, huh? Yeah. Oh, no, 2 by 2. But that's what I'm wanting you to do on part C. Part C will answer it using inverse. This one, I want you to solve it in your method. I wasn't your Algebra 2 teacher. I wasn't your Algebra 1 teacher. They might have taught the calculator, which really breaks my heart. But there are ways to do this by hand, not using the inverse method that we just learned. This method I'm going to show you is called the addition elimination method, and is how we get to what we call a row reduced echelon form of a matrix. We're not quite there, but that is where we're heading. And we use it basically with a matrix sense to get rid of the letters. So you don't have a whole bunch of letters and plus signs and minus signs all over the place. But before we get to that point, let's just learn how to remember how to do this, or maybe just learn it for the first time because you weren't taught it properly. All right, first starters, what's my pre-step? All right, I'm going to write my B up here because I don't want to move my stuff. But yes, I need to put it in the correct order. What do I need to do? I need to subtract the 2y. So this will now be written as 5x minus 2y equals 8. Is my first equation good? That's my first equation's good. 2x plus 10y equals 3. So before I taught you what you learned yesterday, you were supposed to have learned this process. This process is basically you are coming up with some numbers that you can multiply both of these equations by, that would, when you add the two equations up, would delete or eliminate a variable. What ideas do you have? What could I multiply the first equation by so that it would, when I add the two equations up, it would eliminate a variable? So if I times this by 2, this will become a 10. Won't eliminate the 2. This will become a -4. Would not eliminate a 10, but good idea. So what number could I multiply the first equation by so that when I add the two equations up, it eliminates a variable? It can either one of them, yes. What? Okay, let's focus on just the 5 because Jacob had already said 2 and that didn't work. So if we try 5, I do get 5 times 5, which is 25. Doesn't eliminate the 2, but when I come here, what's 5 times -2? -10. -10 plus 10 would be eliminating a variable. So let's work with 5. So I'm going to multiply that second equation by 5. And as long as I do it to all the terms in that equation, it's a completely legal step in math. So I'm going to rewrite it now as 25x minus 10y equals 40. And then 2x plus 10y equals 3. Again, this is called the addition elimination method because at this point, I'm going to add the two equations together to eliminate a variable. 25x plus 2x would give me what? 27x. -10y plus 10y would give me 0 y's. I have eliminated a variable. 40 plus 3? 43. Now I can solve this. How would I solve this? Just division, right? I would divide both sides by 27. Does 43 divided by 27 simplify? Doesn't go by 3. I'm pretty sure 43 is a prime number. Yep. So therefore, here's your answer. How do I solve for y? Anybody remember or have an idea? You could do it the same way. You could find a new number to multiply to eliminate the x. But in this sense, since I already have x, I'm going to plug it into any formula I want. I can plug it in here, here, or even this one right here. Which of these three equations do you want to plug x into? When you say second one, do you mean this one? Okay, it's fine with me. It really doesn't matter. I think it's about the same amount of work. So this is going to be 2 times 43 over 27 plus 10y equals 3. What would I do first? Good. I'm going to distribute. So 2 times 43 over 27 would give me, good, 86 over 27 plus 10y equals 3. What would you do next? I would subtract this 86 over 27. You're more than welcome to use a calculator at this point. 3 times 27 would be 81. 81 over 27. Is that negative 5 over 27? Yep. All right. So it'd be negative 5 over 27. And then what will be your last step? Divide one more time. What is negative 5 over 27 divided by 10? Should be negative 5 over 270, which would actually be negative 1 over 54. 1 over 54. All right, there you go. There's your answer. So using algebra, you got 43 over 27, comma, negative 1 over 54. Now, I'm not expecting you to be able to do this with a 2x2 matrix because in part C, what method did we just learn yesterday? What could we have done? I could take this matrix that I have right here, find its inverse, multiply it to the B, and get the answer. Do that now on part C and verify that we get the same answer. So on part C, you're going to be practicing what we did yesterday, and you're going to use this equation right here to solve using inverses. So do what you did yesterday to solve that equation. Produce your LXB, find the inverse of L, multiply it to B. Again, we're all doing that right now on part C. Not doing what I just did. You're doing what we did yesterday with the same ones. So this right here. So since we already turned into this one, use this one. And we're just going to verify that the algebra we just did by hand is the same answer that our inverse will give us as well. So verify that real quick so I can move on. No. These are the answers that I got. So you're going to use this to see if you get this as the answer. Mm-mm. No. So what? So remember, I'll help you out. Let me get to part C. We're verifying that the work that we did yesterday is the same amount of work that we just did just this second. So in part C, we're just verifying that the way that we did it yesterday is the same way that can be solved in what you learned in Algebra 1 and Algebra 2. There's a reason why I just did part B like that rather than just skipping to part C. And you'll see that in the next problem. Exactly. It's what it's equal. So if this is your, so again, where's the equation? So this is what you started with, right? You deformed your equation from part A. So this is what we got. We rewrote this as 5x minus 2y equals 8 and 2x plus 10y equals 3. This is what we just had, right? So to produce it, it would be 5, negative 2, 2, 10. You're trying to find that xy, and it's equal to 8, 3. Go from there. All right, now that I see pencils not moving as much, are we ready to go over it? All right, so remember the pre-work, gotta make sure it's in standard form. The pre-check, gotta do our AD minus BC. So this will be 5 times 10 minus negative 2 times 2. 5 times 10 is 50. What is negative 2 times 2 going to give me? Positive 4. 50 plus 4 gives me 54. So does this have an inverse? So it is solvable. We already did that in part B to prove that it's solvable, but it still holds here. Go find my inverse. So it's going to be 1 over 54. What's my new matrix? Multiply that to 8, 3. Very good. Row by column. So row, column. So 10 times 8. 2 times 6. Oh, you're right. Thank you. 2 times 3 is 6. And then row, column. So negative 2 times 8 plus 5 times 3. Oh, I forgot to carry over my 1 over 54 here. 80 plus 6. Negative 16 plus 15. 86 divided by 54. Good. And then negative 1 over 54. And again, I would simplify. You could simplify in this step if you would like, but that would give you that 43 over 27 and that negative 1 over 54. Is that the same answer that I got in part B? Yes. So I definitely know this process that we learned yesterday is definitely concrete, definitely works. Which process is easier, part B or part C? Part C. So make sure you're able to do that. Now, this is solving 2 by 2 equations. That is a two-dimensional space. We are in pre-calculus, and we also talk about three-dimensional space. So let's talk about how we can solve a 3 by 3 matrix. Any questions off of yesterday and 2 by 2 matrices using inverse? Pre-work, make sure it's in standard form. Pre-check, make sure there's an actual determinant to find an inverse. Step 1, find said inverse. Step 2, multiply it out and simplify. Right? Super straightforward. The hardest part is probably just creating the system itself. All right, so let's look at the next part. Again, same process as before. You're going to build an equation on part A. I'm going to give you a couple minutes. I want to see if you can produce all 3 equations. Remember, turn words into mathematical symbols if possible. If you are solving 3 equations, how many variables should I have? Have 3 variables. If they're labeled A, B, C, that's perfectly fine, but know what A, B, and C are. Again, on the ACT, I think they just make you just write out the equation. I don't even know if they make you solve it. This one's actually a pretty straightforward compared to the one we had to do a while ago. Oh, a 3 by 3 matrix. You're producing 3 equations. All right, I'm not really seeing pencils moving. So do we have the three equations done, or are we just staring at the paper, hoping the equation shows up like invisible ink? I got you. I see what you're talking about. Yep. Yeah, you should have three equations with three letters in each. Now, there are situations where we can get three equations and one of them might have one or two letters, but not in this situation. We're not quite ready for that. First equation should have probably been the easiest. Right? It says Dylan is designing a card game where different colored cards are assigned point values. Can I turn any of those into math symbols? Not quite yet. I don't really know much information other than that, so I can't turn any of those. It does say Krishna is trying to find the value of each colored card. Again, can I pull any math symbols from that? No. So it's like unnecessary or pre discussion in a story, right? Dylan gives him the following hints. Anything I can pull from that? No. If I have three green cards, one yellow card, and two blue cards in my hand, my total is 9. That gives me some information. What are my three variables? Okay, what are you letting A represent? Perfect. Always label what your variables are so when you go back and solve, you know what each one represents. Good. All right. So 3 green, good, represents 3A. One yellow would represent 1B. 2 blue would represent 2C. And if you did X, Y, and Z, that's what that would be as well. And the total is 9, right? Again, total is adding, and the is there is sum, or not equal, right? If you see the word is, it's an equal sign. Total is another word for adding. Then he kind of gets a little descriptive here, and he goes, if I discard one blue card, my total changes to 7. So how many greens does he have in the second one? He still has 3. How many blue cards does he have? Oh, my bad. Sorry. Yellow. I get distracted with these letters. I still got 1 yellow. And then blue, I have now only 1 blue. Yes, sir. 9, 1 equal. Not quite. Yeah. Because now this new total is going to equal what? 7. Right? The only thing that changed is we took 1 blue card from that. Now, typical of these equations on the ACT literally would just give you like another list. If Bob has this, he has a total of this. This one got a little bit descriptive there and said, oh, just take 1 card, write another equation for him. If I have 1 card of each color, green, yellow, and blue, my total is 1. That'll make no sense. Well, whatever. It's not my game. All right, so how would you write this out? 1A plus 1B plus 1C equals 1. Right? And again, if you used X, Y, Z, that's probably just as good as A, B, and C. Or maybe use G, Y, B for the actual colors. Totally fine. It doesn't matter. Variables is something we don't know. All right, now I want to show you how to do this by hand because it means, oh man, I got to put that in the charger because it means so much to me. But Braden, how much longer do I have in class? I know you keep it on timer there. 11 minutes. All right. I'm going to show you how to use the correct method versus the long method on this one here. So in part B, it does say solve the system using any method you choose, meaning substitution, elimination, or graphing. We're going to skip that for now. Don't put a big X. I like to talk about it one day, but we're going to skip it for now, and we're going to move on to part C. Okay. So in part C, it said let X equal XYZ and let B equal 971. I want you to find a matrix L so that the linear transformation equation Lx equals B would produce an image coordinates that are the same as the solution of the system of equations from part B, but we haven't done part B. So what is basically asking? Take this equation you just formed. And we're skipping B for right now. And I want you to produce this equation, LX equals B, with this information. I'll give you a minute to be able to just write out. You're not solving it right now. You're just writing out the LX equals B portion. Again, if I had more time, I'd definitely show you how to do it by hand. Okay. Should have it done by now. So what would the L matrix look like? 3, 1, 2, 3, 1, 1, 1, 1, 1. And then I would multiply that to X, Y, Z. According to this, if you were technically doing it your way, Jacob, that would just be A, B, C, but same concept. And then my B, again, is always what it's going to be equal to. It told us what it was, but again, it's always that equal sign there. So that's 9, 7, 1. Questions on how to produce a matrices of a 3x3 equation. Right, be able to go forwards and backwards with this. Now, when we move on to part D, it says now enter matrix L into a software program app. I could show you how to find the inverse of a 3x3 matrix, but I would need about 2 more class periods this day just to do the math with you. It is a pretty extensive process of finding a determinant for a 3x3, and then even harder process. I wouldn't even say harder. It's just a long process of then finding the inverse. It's not as clean and easy as those 2x2s. So with that said, if you haven't already, go ahead and get a handy dandy calculator out. If I got their handy dandy calculator, I want you to go to the calculator app for me. Correct. If you don't know how to use these calculators, there's this home button that says on. That's how you turn the calculator on. You can also hit it again. It'll go back to the main screen for you. Then from there, you can choose any of these apps. You can do a new browser. You can even do Scratchpad. It doesn't really matter for this situation. I'm just going to open up a new calculator app. Anybody have questions on how to use a calculator on a calculator? Okay. What we're now going to do is we're going to hit this button called menu. It's on the right side top part. What topic are we discussing? Matrix. Not quite calculus, though. This is pre-calculus. So we're talking about a matrix. So we're going to come over here down to number 7, and we're going to create a matrix. And then you hit the create a matrix again, and you have to put in how many rows and how many columns. How many rows and columns does a 3x3 have? 3 and 3, right? So 3 rows, 3 columns. Watch out for hitting the up and down button. You'll actually change this, so try to use the mouse pad. This right here is a mouse pad on your calculator if you didn't already know that. Okay. Once you have the 3x3 and you hit OK, you produce a matrix like this. All you got to do now is just type in these numbers, which I've done forgot them now. 3, 1, 2, 3, 1, 1, 1, 1, 1. Part D is just simply asking for the inverse. All right. So if you are now looking for an inverse of a 3x3, everyone see this thing that looks like a rooftop, or also known in the computer science world called a caret. Right? Hit that. It makes a little bitty box up here. Right? Type in -1 to represent the inverse of this 3x3. And when you hit enter, it produces the 3x3 for you. If you are a STEMS major and you're going into mathematics, science, engineering, you will be taught how to do this by hand and you will not be given a calculator. So be prepared. Right now, we're just learning about it. I'm not going to force you to do this part by hand. I will say the more you do it, the faster you definitely can get at it. All right, so there's your answer for part D. So just write those results down. You can put it in fraction form, decimal form. I like fractions. I'm going to go 0, 1/2, -1/2, -1, 1/2, 3/2, 1, -1, and 0. So this would be the inverse that I got in part D. Any question on if I'm the inverse of a 3x3? 2x2, I do expect you to do that by hand. So make sure you can still do that. But 3x3, definitely can use a calculator. Part E then says, now create the answer. Go ahead. Huh? You just throw in a 2x2 on the inverse too. I don't want you to. Really? No, I'll let you use a calculator. But you're not going to use a 2x2. You're going to do it by hand. I think we might have to. I trust that you'll do it by hand. All right, part E again says, now calculate the L inverse to the B to verify the results. Again, we didn't do part B, so we're going to be doing this for the first time. So again, we're going to take this inverse and we're going to multiply to the B. So it's the same process as that 2x2. So I take that result I just got in part D. I'm going to multiply it to this guy right here. What are you talking about? The 1/2 and the 1 over the determinant thing. That's its own little equation. So if a 3x3 does not have an inverse, when you type it into the calculator, it will say like undefined or not a real solution or something along those lines. So you'll know at that point this is an unsolvable three equation system. When you're saying 1, what specifically are you talking about? We don't know what the determinant is of this. So in this example, when you're using the calculator to do the 3x3 and you're putting the -1, it's already calculating that 1 over its determinant for a 3x3 and applying it to its method of changing up the numbers and changing the signs inside that process. It's doing it all at once for us. Yes. That's why we end up getting fractions in our inverse, because it did that process for us. Right, after this point, we just got to work it out. And since I don't have much time, a bell's about to ring, you would simply just go to your calculator, scroll up to select it, hit enter to copy it, menu, matrix, create. I'm now going to put that part B, so that's going to be a 3x1 matrix, which was 971. And there's your answer, a 3x1. So your answer in this situation would be 3, -4, 2. So that means if A represented was that green card or whatever, the green cards are worth 3 points. The yellow would have been worth -4 points, and the blue would have been worth 2 points. How else do you go to the matrix?